what is really big data from let me say, human perspective, not technical perspective, because the new world of big data requires a lot of technologies. So we cannot have big data without a good internet connectivity, or who is sending this amount of information. So we need IoT, we need a lot of sensors if we want to fulfill, to populate these big data storage systems. And afterwards, we need also analytics if we want to have big data. Well, the thing is that I think that we have already described big data in different descriptions, definition, but I would like to bring this definition coming from the EMA, from the European Medicine Agency. I think that this is a very good definition, and you can see the date. It's very recent, coming from 2019, only 2 years ago. They defined big data as that, as an extremely large data set, which may be complex, variety. Remember, the variety is related to the complexity, multidimensional, unstructured, and heterogeneous, which are accumulating rapidly. This is the velocity, the V of the velocity that we have introduced several times, and which may be analyzed computationally to reveal patterns, trends, and associations. In this definition, we have all the ingredients to understand big data. We don't have big data if we don't have these three V's: velocity, variety, and volume. So let me bring an example. If you have an external hard disk with thousands of pictures of your wedding, your holidays, your family, and you have petabyte of these pictures, this petabyte is not big data. It's not big data because you are just storing pictures, and we need variety if we want to have big data. And depending on the velocity that you can access to some specific picture, that won't be neither big data, because big data means velocity accessing to the information. So remember, a hard disk drive, external disk drive with 1 petabyte of pictures, that is not big data. Okay, so if you need for your researchers or your internal presentations to use a very good definition of big data, I like a lot this one coming from the European Medicine Agency. It's very good. Well, we saw this slide yesterday. Just it's a very short recall. Very important. The 90% of the data that we have around the world has been created in the last 24 months. And we are generating per day 5 exabytes per day. And important, if we talk about big data, we need to talk about information, because we are not with big data. Only big data is not knowledge, is information. We need to talk about governance, how to manage this amount of information. And this is the output. We don't want to store data only because we want to have the data already stored. We want to store big data because we want to get knowledge from this big data. And here's where appears the data analytics that we have not to miss, or we have not to play in confusion with the AI concept. Okay, it's different talking about data analytics than talking about AI. Well, again, what is big data? Volume, velocity, variety. Do you remember that when we talk about cobots, collaborative robots, when I'm mentioning, or where I'm pointing out to the smart industry, we're talking about sensors, but not only sensors inside the robots, social media, pictures, videos, transaction records, cell phones, GPS signals, everything that is electronic is data, is raw data. Okay, so the only condition, the only requirement is that this data is digitalized. Is the only requirement. But big data has the ability to work using this non-structured data. And which is the enablers talking about big data? Well, We talked about the storage. You remember the storage is 1 cent per gigabyte with full backup and also regionality. So when we talk about this gigabyte and the cost per gigabyte was 1 cent, we're also including here the multi-location. So Google and Amazon, they're providing these requirements. Backup, continuous backup. They have already multivirus, encryption, security, and multi-location. Okay, well, but we have more enablers, not only storage, connectivity, the cloud that we are going to talk in just in a while, supercomputing, the analytics software. So could you imagine how many AI algorithms we have nowadays? Every day, we have 75 new algorithms, new AI algorithms available in open source libraries. So this is, again, talking about open innovation, is how we can democratize AI. But we have libraries like Keras, TensorFlow, they are open source, and they are continuously evaluated by experts, and you can use them for free. And another enabler is Internet of Things. Internet of Things maybe is the source, is the connection between the floor, the physical world, with the cyber physical, the cyber reality, let me say, with the virtual world. Okay, so this is the big data enablers, the storage that we already mentioned before, but here we have also not only storage, also the number of transistors and integrated circuits that were inventoried since the 71 till 2016. Could you see the scale is exponential, it's not linear, it's exponential. So we're talking about a huge amount of chips, circuits, year. This is the this graphic was used for Moore in order to create their own law, the Moore's law. The Moore's law says that the exponential activity based on electronics and computers are due because the number of transistors and integrated circuits are increasing the capacity and the power computing. So when we talk about the Moore's law, is because that he demonstrated his law, his exponential trend, thanks to the number of transistors. Well, more examples. So in 2004, MapReduce. MapReduce is a patent. Well, initially was a patent, and later Google decided to publish this patent and make public, and they transformed this patent in a paper. MapReduce is the technology and the technique that describes how to implement big data. That happened in 2004. Hadoop is the tool that implements this, this technology, this strategy. Hadoop was created in 2006, 2 years later than Google published this paper. Nowadays, this technology, MapReduce with Hadoop technology, is free, open source, and you can implement that by yourself. So you can implement your own big data system using this knowledge because they are public. Again, remember, we're talking about open innovation. This is the difference between the other industrial revolutions that we have experimented in the past. This industrial revolution is pushing to this open mindset regarding the innovation. So you can implement for free. The only thing that you need is knowledge. And if you want to implement by yourself, you will need also data centers and so on. But you can also hire, you can rent this kind of technology to the cloud providers. But if you want to do it by yourself, the cost is zero because the knowledge is there. And this is the two main, let me say, there are many nowadays because there are a lot of refinements and progressions and evolution of both technologies. But with MapReduce and Hadoop, you can create your own big data system. Okay, so very important concept. Big data usually has been used in science, for example, for clinical trials, in order to find out adverse effects or in order to identify new drug purposing So this is existing drugs that can be used for other topics or other diseases. Well, big data is the science of what, but with big data, you cannot know the why, the source of the problem, the reason, the root cause. With big data, you can work with the thing, with the results, with the symptoms, but you cannot help the problem. Okay, so this is important from a scientific perspective. So you need data analytics, you need AI if you want to go to the why. With what, we cannot do it. Okay. Let me bring now an example in order to know which kind of benefit we can get from big data from an industrial perspective, but out of life science area. Do you know UPS, how UPS was using big data in order to optimize their trucks and their services? This is a very famous use case of UPS, this famous company that is transporting packages around the world. Well, this is the thing. UPS was a huge expense every month in gas, in petrol, and they required to reduce the cost of the company because, well, they were to be competitive with DHL and other transport companies. Do you know what they did? They put a lot of sensors, IoT sensors in their trucks, in the smoke escapes, in the tires, in the wheels, in, well, everything. They put a lot of sensors. The thing is that after 1 year gathering data and more than 80,000 vehicles connected and downloading data every day from these vehicles, they found a good way to reduce the cost of the petrol. I don't know if you have driven any time in San Francisco, in California, but this is a chaos. But in regards to that, if you drive your car in California, when you are in front of the red traffic light, in this state, you can turn right if no one is coming from your left. So in Europe, this is forbidden. So when you have in front of you a red traffic light, you have to stop. Yes or yes. There is no way. But in California, you can do this turn, turn to the right. Only that. Well, they identified using big data analysis. So just remember aggregations and anomalies. Do you remember that we have described this several times? Just detecting which kind of routes they have more turns to the right during the track of every day, they identify that these tracks were saving a lot of petrol, a lot of gas at the end of the month. What they did, UPS nowadays, they are optimizing the routes that the tracks they have to follow in order to make the deliver, maximizing the number of turns to the right. Okay, so this is what they did, and nowadays they are saving a lot of money just doing that. This is the numbers. So they were, well, the equivalent. They reduced the distance and the petrol in 10 million gallons of fuel in annual savings. Could you imagine that? It's not only for the cost; it's also for the climate. This is a really good way to implement that. Well, this is using big data. This is an example about how to apply imagination, big data, and a requirement. And again, I think that this slide is appearing now the third time in the workshop, because I think that is very, very important. It's related to the what and why. Big data is the science of what, not the why. Using big data, we can identify these kind of anomalies based on the commonalities. Big data by itself, without any other help, is not useful, only having this data already stored. But just putting some mechanism in order to identify these anomalies, you can have this kind of knowledge. This is very simple. Just putting the big data in a anomaly detector. Only that, without AI, without data analytics, only that could bring value. And this is what, for example, the NASDAQ is doing every day. Okay. And well, I have talked a lot of times about the 3Vs, velocity, volume, and variety. But I would like that you have an image, a picture of these 3Vs in your mind. And to do that, I have a good example for you. Let me show you that. This is how internet works now. Since I made click, this is the number of gigabytes that are being processed to internet. So could you see this is the number of gigabytes that we are now sending to the internet? Well, the thing is that if we go to other actions, for example, how many tweets since I made click? How many likes Facebook received since I made click? How many posts we have in Facebook? Could you see these numbers, these figures? I have other that they are more interesting. This one, the stories, and I like this one. Sorry, this one. This one. This is the money that we spent since I made click in Amazon. Could you see how the figure is growing up since I made click? And if we go to Google, this is the number of searches that everyone around the world is doing in Google. Do you remember the Google Trends tool that I presented several times during the workshop? Well, this is because Google Trends is fed by these searches. And this is the revenue that Google is taking from these searches. So please take this picture with you because this is the synonym, this is the equivalent concept of big data. Could you see? A huge volume of data. A variety of information. We're talking about money, we're talking about messages, we are talking about likes, we're talking about many things. This is variety and velocity. We are so quick, so fast accessing to this information. So these 3Vs, please retain these 3Vs in this picture, because this is how we can define big data nowadays. And this is the numbers. If you are curious, I can keep that since the beginning in order to know how much money they are earning. Well, Amazon is earning a lot of money. Let's continue, because if this is clear, I think that you will have a good point. When we talk about big data, and this is the 3Vs that we have observed just right now, we have mentioned several times that in biomanufacturing, pharma, and medical value chain, we need this veracity and this validity. Of course, this unstructured data coming from different sources, from manufacturing, from doctors, from the health, electronic health record, from the medical health record, for the systems that they are manufacturing processes, whatever we have, we need this kind of ingredients in order to rely on these conclusions. Okay, and we will go in detail. Attributable. So this is the data integrity principles covered by big data cloud technologies. The data integrity, if you want to navigate a little bit through Google, or you can go to the FDA webpage, you will see that they defined data integrity like attributable. So data must be always attributable and assigned to the source of who is originating the data. Otherwise, we cannot use this data for biomanufacturing pharma industry. Data must be always legible. This is very important. So Oracle, Microsoft SQL Server, if you go to the data, you need always their own systems, their own software in order to read the data, the raw data. Why? Because the raw data is stored in a binary system, and the binary system is proprietary from these big companies, Oracle and Microsoft SQL Server and whatever. But by requirement, by law, data must be stored always in a legible format. That means that if you decide to use a specific software that is encapsulating the raw data in a proprietary system, you need to have, by law, always updated the software that you are using for reading this raw data, and always available. Okay, so this is very, very important. Contemporaneous. What does it mean, contemporaneous? Means that the timestamp, the original timestamp, must be always linked to the data that we are using. Okay, so as you remember, we talked yesterday about the validity of the data. I talk about metadata. Please, when you are defining your data, please attached always join the timestamp that when this data was acquired in UTC format, because you never know when this data will be used in other countries, and the time zone where that you were using when you acquired this data. Okay, so contemporaneous means that the real timestamp must be always linked to the data that you are using. Original means that you need to work with the source of truth of the data, or you can use a true copy. Okay, accurate means that you need to add all those concepts around the values that you are inserting that brings value to the raw data. Metadata, like which is the regional settings, which is the IP address, which is the geolocation, which is the unit of measure, and so on. This is how we can make more accurate our data. Well, this concept, these data integrity attributes are very known in the pharma industry, like ALCOA. Okay, we are using the acronym of the initials of this attribute. ALCOA is the attributable, legible, contemporaneous, original, and accurate. But we don't have enough with that. We say, or we call ALCOA plus, when we need to complete this information without to consider potential limits on the data. Remember, we're talking about big data. So we cannot consider computers or on-premise systems or cloud systems where we have to suffer a lot in order to keep consistency and the space enough to guarantee that data is always well stored. So we have to be consistent with the data. So they have been, we can create automatic audits. We have to establish full traceability. And so we have to ensure that the data is perduring during the required time by the law. For example, in Europe now is 5 years, and availability. So internet bandwidth, what we're talking about, the geographic distribution cloud platform, and this availability maybe is related with the weaknesses that we identified today about bandwidth. Well, the good news, so maybe that is could seem that it's so hard to be compliant with, but in big data tools, we have everything in place to be implemented for free. So, for example, attributable. Let me introduce you some example. In attributable, we have the PGP concept, the certificate, the multi-factor authentication. So we have many tools that can help us in order to make attributable at the raw data. And here you have an example. This is the PGP. In the Massachusetts Institute of Technology, you have available a server where you can create your own public key and private key. And this is very useful and very used in big data in order to sign every single record with your own electronic signature that no one can replicate. Okay, so PGP is a very good tool, free, open source, that is very used in the attributable. Legible. Do you know what JSON is? Legible. Well, I think that this is important and it's worth to describe. JSON is the building block of big data. without a JSON structure, we couldn't work nowadays with big data. What is JSON? What is a JSON format? Do you remember some years ago that people were talking about XML format? Well, JSON is something similar, but lighter. For example, let me go to an example. JSON editor. JSON editor. Let's go to that. Okay, this is a JSON. Let me delete that. A JSON is a very simple structure where we have this kind of keys, and you are defining a field, for example, a column like, for example, imagine we see test measure, and we have a value. For example, we see that this is 1.5, and we have here the name. We're measuring that density or test name. Test name. This is density, and we have unit of measure, and the density is grams per centimeter cubic. And for example, let me add another one that says verified, and I will see yes, sorry, true. Okay, this is a JSON that contains a row, a record, a data raw data. That imagine that we have to do that using classical tables, Excel files, Microsoft Access, spreadsheets, classical relation tables like Oracle or Postgres or MySQL or whatever of these data. Do you know how to go to the raw data, to the real raw material that you are storing using this kind of tables? At the end, you arrive to a binary file that is compressing the data. But using JSONs, and this is the content of, this is big data, this is the building block of the data, big data. Big data is storing this kind of objects. This is an object that contains this information. Okay. And well, the thing is that you can transform that. You can transform that into objects where you can ask for, give me all the test measures that they are between 1.5 and 1.6. Give me all the densities. Give me all the measures that has not been verified, and so on. Okay, so this is the kind of things. And could you see that the system is able to identify that like fields? But in Oracle, in SQL Server, in any kind of classical databases, you have to define each column as a number, as a string, as a boolean, and you have always to follow the same pattern. Otherwise, the value cannot be stored in these databases. Well, in big data, that is not happening. In big data, you can store this information without to know if this is a number, this is a string, this is a boolean, this is whatever, because the JSON knows what's that. You are saving a lot of space, and you can create a new JSON with another format, changing whatever you want. So this is the building block of big data, and that it's very simple. It's a very dummy thing, but this is thanks to that we have big data today. But this is also granting this is always legible. Could you see? We are not using any binary system. We are using raw text, and it's always legible. Contemporaneous. So we need to have always in our systems a NTP synchronization, and you have a lot of free resources. For example, this one. We have the full ntp.org, and you can define which is your zone, Europe in this case, or whatever zone you belongs to. And you will have the different servers that is bringing to you the official synchronized timestamp. Okay, another open source that you can use for ensure the contemporaneous data. Original, accurate. So we have a lot of helps. So you have that in your in the slides, in the slide deck. But remember, I think that this is so important. There is a huge amount of tools that you can use bringing with big data in order to guarantee, in order to ensure the validity and the veracity of the data. I hope that that helps to all the people that is working nowadays with big data in regulated environments, in life science, because this is really important. So we're managing gold, and this gold must be really cleaned up. We have to preserve this information from any kind of external violation. At the end, we are serving to patients, and it's important to follow these rules that well, we have to be agreed on that. But the good thing is that this kind of essentials can be implemented in big data technologies for free. And well, talking about the total health and big data market, the evolution, could you see which is the evolution here? So we are talking about early adopters in the 80s regarding digitalization. And nowadays we are talking about a reality. So when we started this this afternoon, we were talking about that we are not seeing still in our industry or in our countries a very strong evolution in the industry. Well, believe me, there is a non-stopped push that at the end will go to this direction in any way. Maybe we can spend more time, more years, or less the years than other ones, but at the end that will arrive because it's the full society that is pushing on this direction. And this is the global view, the global roadmap and future opportunity established in 2017 and how it works in 2002. So this roadmap, I encourage you to work with if you want to create this roadmap internally, because this is coming from Frost and Sullivan regarding how big data could be implemented for healthcare. Well, Frost and Sullivan worked on that in 2017. The thing is that when they established this long-term, between 5 and 6 years evolution, they were really good with their forecasting. Everything they envision is happening nowadays. Okay, for example, applying analytics to DNA of cancer cells. That was, this slide is coming from 4 years ago. And they foresee, they forecast that in 5 years, the DNA cancer cells will accelerate adequate care services. Well, probably you already know that the mRNA vaccine is precisely based on this technology. So this is really good to read. And this is the healthcare big data market. Okay, we saw how we can have big data in terms of life science. We have two main markets. One is how to manage, how to organize, how to govern, how to create governance on this big data management. This is one thing. How to share, which kind of policies, how to bring access, how to be compliant, how to provide services to external consumer of this data, and so on. This is the first market, how to create big data management. And the second market is how to extract knowledge from this data, visualization, AI, analytics, and so on. Well, this is the vision of Frost and Sullivan in 2016, and this is completely valid nowadays. So these two different markets, they deserve a specific industry for each one. And if you want to make business in this area, in life science, with big data, both topics are really good. So maybe just an idea, maybe this data could be very useful for other companies. Why not to create a market based on the knowledge that you are bringing? So this kind of new markets are emerging nowadays. Actually, they are a reality nowadays. Do you remember that we talk about Kaiser Permanente and other insurance companies, hospitals? They are using that nowadays in order to prevent, in order to detect quickly potential diseases or root causes of problems that they are happening. But there is an emerging market on that, and this is a very good opportunity to add value in your existing products and services. So remember that we were talking about innovation. We are always pointing out to the ability to add value to your patients, to your users. So how omics research, how clinical trials, how patient records can have a value using this big data coming from different smart systems, iWatch, smartwatches, and so on. So the idea or the final goal, if you want to be competitive nowadays, is not be predictive. If you want to be competitive, you have to think on prescriptive analytics. This is the key nowadays. This is the 5.0 industrial revolution that we were talking about in the first day. Nowadays, we are working in diagnostics and predictive. Remember, descriptive is not enough. We need to make diagnosis. We need to be predictive. But the goal, the final goal, to be in the competition is to be prescriptive.